Okay, guys, I want to continue where we left off in the notes, and then once we finish up the section in the notes on fossils, we'll take a look at pictures of fossils, and I'll actually show you the real fossils that I happen to have here at home. Again, I didn't really plan on bringing fossils home. I just happen to have some here anyway, which works out well for this unit, so we can look at some of those. Anyway, we were talking in the last video about how fossils are largely found in sedimentary rock, or almost entirely found in sedimentary rock. There are some exceptions, though. Fossils are almost never found in igneous rocks because of the magma. Igneous means ignite, and we're talking about lava. So if an organism dies near lava, well, that organism burns before it can form a fossil. I've only ever seen one fossil in an igneous rock, and it happened to be some sort of leaf or plant material that fell into the lava, and then the lava cooled and hardened quickly enough where the fossil or the plant didn't completely burn by the time the magma hardened, but extremely rare, extremely rare. So this is very unlikely. And it's also unlikely to find a fossil in a metamorphic rock. It can happen, but again, it's very rare because of the heat and the pressure. The heat and the pressure destroy the fossil. So, if we had a fossil in a sedimentary rock, like a shale or a limestone, and then it undergoes metamorphic processes, the heat and the pressure have a tendency of destroying, crushing, breaking that fossil. It can happen, though, on rare situations. So again, very rare, but can happen. Very rare. Okay, so very rare, can happen in some situations. Now, when a fossil does form, sometimes what we see, and I might have an example of this, I have to look, is what's called a cast and a mold. Well, when this happens, sometimes we have an organism die and it gets buried, and sometimes, if we're careful, we can take a rock and split it in half. And when we have the two halves, sometimes on one half we have an impression of the creature, and we call that the mold. Just like if you were to use like a candy mold to pour chocolate into and make like a chocolate Easter bunny or something like that, that would be the mold. It's the impression of the creature. On the opposite side, we would have the cast, and this would be the raised representation of the animal. So we have what's called the mold, which is the empty space in the shape of the organism. And then we could have what's called a cast, which is when the minerals fill a mold and it hardens into the shape of the original organism. This is what we call a cast. I'll see if I have an actual example of that. I'm not sure I do, but I might. So let's take a look at other ways that fossils can form. We can have casts and molds. Sometimes we have imprints or impressions. These could be tracks, but they could be other things too. Feathers leave impressions. We could see impressions of leaves and things like that. Tails. When some animals walk, their tail drags on the ground and leaves a trail of the tail in the mud. And eventually that mud later hardens into some type of sedimentary rock. Many of you have probably heard of amber. We took a look at amber back when we were doing rocks and minerals. Amber is fossilized hardened tree sap. Occasionally insects get trapped in that amber, just like if you've ever seen the movie Jurassic Park. Sometimes people ask, well, could Jurassic Park really happen? We can certainly have insects trapped within amber, and those insects could be 60, 70 million years old. The concept for the book and the movie is very cool. In reality, though, the DNA is probably too old to actually reconstruct something like a dinosaur or some creature from the Jurassic period or the time when dinosaurs lived. There are researchers, though, that are trying to work with more recent DNA from creatures like woolly mammoths and mastodons. Woolly mammoths and mastodons are similar creatures. Woolly mammoths were larger. When they died, they were often preserved in ice. The animal died. Woolly mammoths, mastodons are related to modern day elephants. Mammoths, much bigger. Mastodons were probably more like elephant sized. Mastodons lived in this area. We have a lot of mastodon remains in this Hudson Valley region. Mammoths were in different places though. Anyway, the animal died. These creatures lived during the last ice age, died in ice, and were preserved in ice as the snow fell on top of them. Some of these creatures are so well preserved that when they thaw, there's even been accounts of people in Siberia actually eating the meat as it thaws out of the ice. Thousands of years old, but preserved in that ice. So one of the things that's really interesting about preservation in ice is that we have skin, you have flesh, you have organs, you have hair. The things that would normally decompose are preserved. So we have a better picture of the animal, what it was really like. Again, this goes back, not that long ago. Last ice age was 11,000 years ago. So we're not talking about millions of years ago like we're talking about with dinosaurs. There are some researchers that are trying to take some of this DNA and genetic material from these mammoths and mastodons and implant them in the embryo of modern day elephants and are trying to bring back the mammoth and the mastodon. Last I read, there were some Chinese researchers that were attempting to do this. Basically the concept from Jurassic Park, but they're using more modern DNA. The DNA structure is broken down too much, disintegrated too much in something like a dinosaur to really do that. But with something like a mammoth or a mastodon, possibly not. It's a more recent animal. It could work. Anyway, ice gives exceptional preservation. We have a record of what the skin was like, color, flesh, organs, hair, everything. Tar, naturally occurring tar, the La Brea tar pits out in California can preserve creatures. Animals fall into the tar pits. Tar is a black, sticky, oil-based material, and it occurred naturally in pools. Sometimes creatures would fall in and die, and we would have preservation that way. In order for decomposition to happen, we need oxygen, and we need water. And in a tar pit, you have neither of those. You lack those. So we have preservation in tar in some situations. We have petrification. Many of you have probably heard of petrified wood. And in this case, minerals dissolved in water gradually replace tissue of plants and animals. So in this case, the organism died, whether it was a plant or an animal, and minerals dissolved in the water over time replace the original tissue and cellular structure, and it's a replacement. Of living tissue with mineral material. I'll just say with minerals, because there's many different minerals that can do this. Calcite quartz are very common for this, but even pyrite can do it too. There's another form of preservation called carbonaceous film or carbon film. This usually happens with plants, especially fossil ferns and things like that. All life is carbon-based. And when the organism dies, we have this residue or thin film of carbon that sometimes gets left behind. And again, we often see this with ferns on shale. I have a very nice example of that I'll show you in another video. All right, so why don't we stop here? Let's take a look at some pictures of fossils. We'll look at some actual fossils, and we'll talk about what we can learn from fossils and what the importance is of studying fossils. Fossils are interesting to collect, but we can also just learn a tremendous amount about past life and what the Earth used to be like. All right, so that's all for now, and we'll look at some actual photographs in a little bit.